Hi class, what I want to do in this lecture is I just want to do more confidence interval examples, just showing you again how to use your TI-83 calculator. So have this handy while I work through these examples, and we'll work two different types, one where we give you the summary statistics and one where I give you the data, and we'll talk about how you approach those two problems. Okay, so here's the first problem. An economist wanted to estimate the mean commute time of individuals living in Morristown, New Jersey, okay, my hometown. So what she does is she randomly samples 31 commuters in Morristown and finds the mean commute time to be 28 minutes with a standard deviation of 14.3 minutes. So here what we want to do is we want to construct two different confidence intervals. First a 95% confidence interval and then a 99% confidence interval for the mean commute times, okay? And then what I want to do is I want to see what happens to the width of that interval as the level of confidence increases. So here's what I'm going to do. I'm going to start by putting our summary statistics. So the sample size n is equal to 31. X bar, the sample mean, was equal to 28. And S, the standard deviation, was equal to 14.3. Okay, so let's do the 95% confidence interval first. Okay, so the good news is my trusty calculator will do this for me. So loading this up here, you're always going to start by hitting the stat button on your calculator. And what we want to do is we want to go over to test. Okay, and what we want is we want option number 8, the T interval. Right here. So remember, here I'm giving you the summary statistics. So I'm going to go over to stats, and I'm going to hit enter. And X bar, that was 28 minutes. S sub X is the standard deviation, so that was 14.3. And N, if you remember here, was 31 commuters. So I'm going to leave the 0.95 as is, because I'm going to start with the 95. I'm going to hit calculate, and I'm going to round this to 2 decimal places. So it's going to be, it looks like I'm 95% confident the average commute time is 22.76 minutes to 33.25. So it was 22.76 to 33.25. Okay, now let's look at that 99% confidence interval. So what you should see here is as you increase the level of confidence, the only way you can be more confident is you have to increase the width of the interval as well. So let's do that. So I'm going to go back to my calculator, and I'm going to hit the stat button again. I'm going to go over to tests, and again it is number 8. I hit enter. And you're going to notice you're still going to have the 28 is going to stay the same. The S sub X is going to stay the same. The N is going to stay the same. The only thing that's going to change here is my level of confidence is now going to be 0.99 because I want a 99% confidence interval. So I'm going to hit calculate. And look, now it becomes 20.94 to 35.06. So 35.06. So what we're seeing here is as you increase the level of confidence, the interval gets wider. Right? So that's good. That's what we would expect to happen. All right, let's do one more example, okay? And what this one is this example here is the actual example that was published by Gassot when he introduced the student's t-distribution. So here's the problem. In 1908, W.S. Gassot published the article, The Probability Error of a Mean. In this pioneering paper written under the pseudonym Student, Gassot introduced what later became known as the student's t-distribution. So Gassot used the following data set, which gives the additional sleep in hours obtained by a sample of 10 patients, and I'm not even going to try to pronounce this. I'm just going to call it, using this drug, we're going to abbreviate or call LH. So what we have here is we have the additional hours that people got, okay, when they actually used this drug. So what I want to do is I want to construct a 95% confidence interval for the additional sleep that would be obtained on average for all people that use this drug. So first what I have to do is I have to take this data and I have to plug it in to my graphing calculator. So to plug something into your graphing calculator, you're going to hit Stat. Under number 1, you're going to edit the list. And under L1, you're going to put these additional hours of sleep into your calculator. Okay, so I'm just going to move it off the screen here so I can see it as I type it in. So the first person got an additional 1.9 hours. Somebody got an additional 4.4, 0.8, 5.5, 1.1, 1.6, 0.1, 4.6. Someone lost 0.1 of an hour, so don't forget you have to put that negative in there. And then 3.4. Okay, so all I did was plugged, going back, all I did was plug this additional time right here into the graphing calculator. Okay, so now it says construct a 95% confidence interval for that additional sleep on average. Okay, so now what I'm going to do is I'm going to go back and press the Stat button. Again, I'm going to go over to tests. You want number 8 here, right here. And now you're going to go over to data. So you're going to hit data and you're going to hit enter. And it's going to say your list is in L1. Great. Going to go to your confidence level, and remember I want it as 0.95 now, okay, because this is a 95% confidence level. And I'm going to hit calculate. So it's saying here that on average, we're 95% confident that the additional sleep somebody will get, I'm just going to round this to one decimal place, will be between 0.9 hours and 3.8 hours. So that's our 95% confidence interval for the mean. Okay. So was the drug effective at increasing sleep? Yes. Because on average, we expect people to get more sleep. Since this confidence interval is strictly above 0 here, because it's on average it could be anywhere between 0.9 all the way to 3.8 hours. So yes, this drug was definitely effective at increasing sleep. All right, well, I hope seeing these two examples, extra examples on using your calculator help. And I find that when you use the calculator, this confidence interval stuff can actually be done very quickly and very easily.